Hello everybody and welcome back to Welch's Math class. We are continuing on in our conversation about geometry today. And so we're going to be picking up at sections 8.3 all the way up through 8.5 in your homework from Course Compass My Math Lab. And I want to start this off by talking a little bit about perimeter within geometry. The word perimeter simply means the distance around some figure. So if we were to be able to somehow or another measure the distance around a figure, we'd have its perimeter. That's really all we need to know. So if we have a figure and we know the length of each distance for each side of the perimeter, or for each side of the figure, if we know that, we can simply add up all the sides and have the perimeter. So, perimeter is found simply by adding all the, how should I say this? All the sides of a figure. Okay? So if we add up all the sides of a figure, we'll have that figure's perimeter. We'll have the distance around the figure. Let me give you an example or two, and maybe that'll make more sense for us as we go on. So let's grab hold of a couple of examples. And I suppose maybe we should go ahead and define the figures that we're going to spend our time talking about right here. The figures that we're going to be dealing with here are flat, two-dimensional, okay, straight line, figures. Okay, some folks would call them plane, P-L-A-N-E, figures. All right, so the examples I want to give you of some flat two-dimensional plane figures, we'll start off with one of these. And this is what we would know as a parallelogram. Okay? And so you see a parallelogram actually has four sides. The opposite sides are parallel to one another. The opposite sides are parallel to one another. In a parallelogram, the top of the parallelogram will be equal to the bottom. The left side and the right side will be equal to one another. And so simply, if we know the length of each side of this parallelogram, we can add those up and we'll have the perimeter of the parallelogram. And so let's say this was 8 inches. This bottom is also going to be 8 inches. Let's say that this side right here is 9 inches, and that's going to make this side 9 inches. So the perimeter, P, for the parallelogram is going to equal 8 plus 9 plus 8 plus 9, and all that's inches. And so looks like a total of 34 inches. Let's get that unit down there with that as well. So that's a parallelogram. That is one of the flat two-dimensional straight line figures that we'll look at for perimeter. Another figure that we'll take a look at is a type of a parallelogram called a rectangle. Type of a parallelogram called a rectangle. Rectangle, I say it's a type of a parallelogram. It's a special parallelogram. The angles, if you notice all the angles within the rectangle are 90 degrees. Every angle here is 90 degrees. Okay. But notice that the top and bottom are parallel lines. The left side, right side are parallel lines. If you know the length of, let's say, two of the sides, let's say that this top is 7 feet, and this side right here is 5 feet. We would be able to come up with the perimeter of that because we know this opposite side is 5 feet, and this opposite side here is 7 feet. So P would equal 7 plus 5 plus 7 plus 5, or 14, 10, 24. 24 feet. 24 feet would be the perimeter of that rectangle. Okay? Another figure that we'll look at with perimeter that'll help us out a little bit here. Of course, I'm erasing those. If you need to pause the video to stay up with me to copy those down, then certainly do that. But another figure that we're going to look at, and I'm not going to be good at drawing this, but we're going to give this our best shot here. That's maybe my best shot at this. Believe it or not, that's a square. That's a square. Now, a square is also a type of parallelogram, and it's also a type of a rectangle. The difference is all four sides on the square are equal to one another. So if we were to come here and say this side of the square is 9 yards, okay, so our perimeter would equal 9 plus 9 plus 9 plus 9, or some people just shorten it and say 4 times 9, or 4s, 4 times the side. But if we add all the sides, to stay with one simple formula, add all the sides, and we'll have the distance around. So the perimeter here is going to be 36 yards. 36 yards. Another figure that we will spend some time with would be a triangle. A triangle. Now, when we talk about perimeter of the triangle, we simply have to know the length of every side on the triangle. We have to be able to add all 3 sides up. There's nothing special we can say about one being equal to the other, like we can with a square or a parallelogram or a rectangle. So we would have to know the length of all 3 of the sides in order to get the perimeter here. So if we were to say this was 12 inches and this was 14 inches, and I'm going to say this one is 13 inches, then my perimeter is going to equal 12 plus 14 plus 13. Doesn't really matter what order I put them in. Addition, you can switch the order with addition. So I'm looking at 2639, 39 inches. 39 inches is the perimeter here of my triangle. All right? So we've got a triangle there. I want to show you one more figure with perimeter. Perimeter really, when you get right down to it, simplified as much as possible. A perimeter is simply just adding up the length of all the sides. Okay? Let's show you one more figure here, just to go ahead and get this figure out of the way so you'll know what this is. Another poor attempt at drawing, but this figure is called a trapezoid. Excuse me. A trapezoid. Okay, so a trapezoid will have 2 parallel sides, in this case the top and the bottom, but it doesn't have to be the top and the bottom. I could actually draw a trapezoid like this. Say I could turn it kind of up on its end. Alright, so it has 2 parallel sides. In this case it's the bottom and the top. In this case it's the left side and the right side. And then it has 2 sides that are not parallel to one another. The 2 sides that are parallel to one another are called bases. You might call that base 1 and you might call that base 2. Usually within a trapezoid you're also going to have a dotted line in here somewhere, and this piece right here is the height. Okay, that's called the height. So right here, this would be, the height would run this way at a 90-degree angle. Between the two bases, a 90-degree angle between the two bases, this would be the height, HT for height, and then this would be base, and this would be a base. Okay? So this is what a trapezoid looks like. All that being said, you know the formation of a trapezoid. Now, all that being said, perimeter for a trapezoid, again, is very simple. We just have to know the lengths of all four of the sides. So let me draw another trapezoid up here. All right, so here's my trapezoid. Let's just say, and let's say the bottom and the top. Ooh, that's terrible drawing. But let's say the bottom and the top are our parallels. Let's say the bottom, the base, bottom base here is, let's say it's 18 feet. That's a little shorter, so let's make this 14 feet. Okay, let's draw a height in here on this one. Let's put a height in here. Let's say that height is probably about 6 feet. Let's come on to this end right here, and let's go ahead and throw a number here and call this 8 feet. Now this is going to probably be 7 feet. Now, when we're finding the perimeter, remember, we never go to the interior of the figure. It's the distance around the outside of the figure, and we never go to the interior of the figure. So we're not going to be adding the 6 in here. When we get this perimeter, what we're looking at is the 14 plus the 7 plus the 18 plus the 8. Okay? And of course, when we get that, looks like that's 25, 35 and 4 is 39, 39 and 8 is 47. So 47 feet is the distance around our trapezoid. The 6 feet had nothing to do with it. The 6 feet will be important when we get into area a little bit later. We'll get into area. So perimeter, just measuring the distance around the figure. Now, we have what we call also composite figures. Composite figures are when we take a couple of figures and put them together to make a single figure. So if we do something like this, this might be known as a composite figure. This composite figure, you might say, okay, here's a rectangle right here, and then here's another rectangle right here. All right? So let's say with this composite figure, I said this side right here was, I don't know, let's make that 4 inches. And let's go to this side right here and say this side right here is, I'm going to call that 12 inches. Now, let's go to this side right here and call this, this lower side right here, let's call that 2 inches. And down here, that looks like that's probably about 2 inches also. Okay? I might adjust that a tad. I might actually look in here. I'm going to drop this down to 3 inches. Okay, so suppose I want the perimeter of this figure. Well, what you'll notice is I don't know the length of this side, and I don't know the length of this side. So we've got this composite figure. We want to know the perimeter, but we've got 2 unknown sides. Now, we can certainly add the 3 plus the 2 plus the 12, this side, this side, this side, and this side, this other 2, but we need those sides. Okay, so in order to get the length of, let's say, this side right here, what we're going to do, this is a vertical side, okay? Up and down, a vertical side. We'll look at this vertical side and this vertical side. If you took this vertical side right here and you connected it to this vertical side right here, okay, here, and you put those together, you would have this. So we have the 12 that's here, we have the 3 that's here, so this entire side over here, when you look at it, must be 15. Okay, by the same token, to get this top, this is a horizontal side, we'll look at this horizontal side and this horizontal side. If we take this bottom horizontal side and slide it to right here and put it with this other horizontal side right here, that'd be 2 more. So it'd be 2 to here and 2 more to there. So it looks like we've got 4 inches there. Now you see we've got all the sides. We've got all the sides. So if we add all these up, our perimeter, let me find a good place to add this, is going to be 4, 3, coming around this way, 2, coming down 12, going down some more, 2, going back up 15. I just put this and this here to show you how I got the 15. All right, and then we're back up to the 4. Let's be sure that we didn't leave anything out. I've got 1, 2, 3, 4, 5, 6 sides here. I've got 6 sides. Oh, my lights went out. Let me get those back. Okay, I got 6 sides. I should have 1, 2, 3, 4, 5, 6 numbers. Good. Dimensions. So there's, let's add these up. That's 7, 9. 9 and 2 is 11, and 10 is 21, 23, 33, 38 inches. And that's how we'd find the composite figure. Guys, that's all I want to tell you about perimeter right now. Next time we'll get together, we'll talk about area of these same figures. We'll give you some formulas and work from there. Y'all go do some homework now over in 8.3 to 8.5 and work out some of those perimeter issues. Leave the area ones blank. Just work on the perimeter problems, get those squared away, and then look at the video to get some help with area. Thanks a lot. See you next time on Welch's Math.